Hello, everyone. It's Jonas Lamas here with Tezos Community, and you've joined us for episode 2 of our new podcast called Tezos Today. And I've got a great guy joining us today. My guest is Milo Davis. For those of you who have been checking out the Riot channel and other Tezos-oriented feeds, you'll have seen Milo's name. He's a young engineer. And he's interning with the Tezos Foundation team in Paris. And he is kind of the go-to guy who's teaching everybody about Michelson, our smart contract language. So let me bring Milo in. And Milo, say hey to everybody and tell us a little bit about yourself. How did you get associated with this?
Hi, everybody. Well, I guess this all kind of started back when I subscribed to a mailing list. I really like the programming language OCaml. If you don't know it, it's a ton of fun. And I wanted, for a few years sort of to find a job working in it. And there's this OCaml jobs mailing list. And so I sat on the mailing list, and one day I got an email from Arthur, and went out to everybody, and I sort of clicked around, sort of saw what Tezos was. I had a little bit of familiarity with cryptocurrency, but not a ton. And sort of said, well, this idea is kind of weird and crazy and different from anything else I've heard before. I read the white papers, joined the Slack, and started kind of thinking about, what Tezos was, and realized that it was something that's kind of this crazy experiment that's just insanely cool. It's got this really interesting way it pays off, and it has really interesting applications to government and politics and money, of course, but the dev team sort of has this great mentality that I really like, where sort of the way the problems are going to be solved is through programming languages and through formal verification and those sorts of techniques, and that's where sort of the power is going to come from. And I really identified with that and sent Arthur an email, and we talked, and now I'm here in Paris.
Awesome. So you, I think you've been studying for your undergrad, I would assume, at Northeastern University, and now are you taking a semester off, or how long are you going to be in Paris working with the team?
So I'm going to be here for 6 months total. So one of the things Northeastern does to try to help their students get jobs and, more importantly, real-world experience is they have a co-op program. So you do these 6-month internships. I did a previous one doing natural language processing, research and development work, sort of dealing a lot with sentiment analysis and neural networks. Realized that it wasn't really what I wanted to be doing with my life. And it kind of fit in with this series of programming languages research projects I was doing at the time. And that's when I started looking more seriously at sort of the world of formal verification and sort of the ideas and people that are using it.
Awesome. All right, well, let's get to it. The smart contract language that has been built for Tezos is called Michelson, and you have been spending time with the dev team learning about Michelson, and have in fact been authoring a website, which is kind of, I think, the definitive public source these days on how to write contracts with Michelson, which you can share with us a little bit later. But to start with, can you give us an overview of what this language is all about, why it's different than other smart contract languages that are out there, and why it's so appealing for high value smart contracts?
So I think the way the Tezos team is built, it's from people who have this background in programming languages, and most specifically strong type systems. And so they didn't want to build assembly for the blockchain. And they want to build something that the language itself is going to enforce your security properties, or at least it's going to do a lot to make it hard to write bad contracts. And by bad, of course, on the blockchain, you usually mean insecure. And so the way Michelson is designed is basically you have some very simple systems. It's a very small language. It's meant sort of as a readable bytecode. It's fun to program in. I personally enjoy it. There are going to be compilers, and already are a couple down to it. but you can definitely look at a Michelson contract and understand what's going on. It's not like you're reading assembly and you have to look at a bunch of move instructions, and you can pretty much follow everything through. And then you've got these very strong typing guarantees so that it's very hard to write certain types of contracts, and you can encode a lot of your invariants in the type system, which kind of protects you because the computer checks them. So you don't have to worry about whether you messed it up. If the computer says signs off, you didn't. So that's a very powerful idea.
Awesome. Yeah, go ahead.
So I guess the biggest difference between Michelson and probably other languages that people have worked with, it's stack-based. There are no variables in the language. So you don't have some hello world that begins, let x equal hello world, and then you say print x. You can't do that. You have to think about it in terms of a stack. So you push hello world onto the stack, you push that string, and then you operate on that string with a series of operations, and then the result is returned to the user. And it's a little hard to get into at first, but it's kind of a fun puzzle once you actually can follow it a little bit better. And you could use this architecture to encode all kinds of different things. You can encode a variable system if you're compiling down, and you can use the stack to be very, very concise. So you can line up all of your operations and then just apply them in sequence, because composition is just a sequence of instructions. And then you can do all kinds of things to rearrange the stack and manipulate it and get the data to where it needs to be.
Cool. So one of the things that the dev community is constantly talking about on our forums and on the other channels is how do I get started? What's the first thing that I should learn in order to become productive with this language? And I know that you have a website out there, so maybe you can give us a tour of your site and take us through some basic examples of how the language works.
Okay, yeah. I'm gonna share my screen if that's all right.
Yeah, go for it.
Let's see, desktop. Okay, cool. I think you can see yourself probably. Okay, hopefully this, cool. So can you see this all right?
Yes.
Perfect. Okay, so basically you can see here, there's a lot of stuff going on. It's meant to be an introduction to the Michelson language. There's more content coming. Currently, it's just this sort of contract a day series and some stuff about how to run contracts on the AlphaNet. So to get started, basically, you need a way to run the programs. What's really great is that you can try it online right now. So if I just open this up, you can punch in a contract and evaluate it right here, or at least type check it on this website. I didn't build it, but I think it's a great resource. If you are on the AlphaNet, you can see all of the command lines you need to get the contracts running. And I'm waiting for a script to be merged in a few days, but once that's merged, I'll have instructions up here about how to run stuff when you've compiled the node yourself, and some scripts and resources to make that happen.
Before you go too much further, on the AlphaNet, what's the status of that, and how do people get involved with the AlphaNet?
So the best way to get on the AlphaNet is to get on the IRC channel and ask Arthur basically to be added into it. Once you're on it, you get this alphanet.sh script. It connects you to a network. You're given a certain amount of Tezos, and you can do whatever you want with them. You can immediately trade them to somebody for whatever, or you can use them for contracts. It's very easy to get more if you run out. So it's sort of it's like the blockchain, but it's free and test oriented. You can do pretty much whatever. It's a little bit more relaxed. Obviously, there aren't all the restrictions about you have the amount of money you have. That's just all been thrown out. And then from there, you can register transactions. You can interact with other people. You can spin up accounts and contracts. But what a lot of the stuff you can do here is you can run the contracts locally. And that's a big help when you're trying to develop them. And then you can simulate different inputs. Like you can simulate storage and the parameter passed. And then you can start to actually interact with the contract, launch contract to the blockchain. That's the instruction here. And then you can start to interact with it. You can send it transactions. You can have it hold a certain amount of Tez for you, whatever you're interested in doing.
Awesome. And we'll link up the IRC channel and the other websites that are discussed here today in the description of the video, so people can click on those and find these things.
Fantastic. So I guess continuing through, I've got some stuff about the data literals, because a lot of them are non-obvious and some of them are very long, especially if you've signed a hash. Lambda and stuff. Basically, you're going to need this if you're actually writing contracts and testing on certain pieces of data. So, that's a list. And then you get into basically, I wrote a contract every day. I said I'd do it for a month. So I'm done, I think, on the 24th. So 2 days to go. And there are a lot of different ones. Some are meant to be more tutorial, and some are meant to be sort of explorations of weird and ridiculous ideas. Some are meant to be actually useful. And so hopefully it's kind of it's me figuring out Michelson as much as me telling people how to write good contracts. And I've tried to keep them up to date as different instructions are added or different bugs are fixed and things, so that hopefully you can use this and run the contract and it'll more or less work.
Cool. What is the state of the language now? How much do you see it evolving?
I think it's going to evolve quite a bit. I think there are problems that we still want to solve. And then there are some things that are really nice. I don't see the stack going away. I think people who think that that's really hard to work with, you want to be using a compiler, and there are some out there. There's Liquidity, which is from Fabrice, and there's going to be others, I'm sure. I think I'm going to have a tutorial up here in a few weeks about how to actually build a really small one, and things like that. So I think you're going to see things like that, but I think you're going to also see a lot of the models change. I think you're going to see the concurrency model shift around. Lambda might be tweaked. Different things. There's a lot going on, and a lot that is not yet fully ready. And we're also adding opcodes all the time. Like, for example, there was one I added, like the first thing I added to the language was the default account opcode. And I really like it because it's a secure way to make a transfer. And so you're going to see all kinds of stuff kind of come up over time.
Cool. What are the top couple of things that you're having to provide support on for people new to the AlphaNet and new to the language? What are the major questions you're getting that maybe you can just answer in bulk right now?
I think the biggest thing, the AlphaNet configuring Docker is tricky. It's usually pretty easy for your system, but go find a guide that spells out, I'm on a Mac trying to get Docker to work. Someone has written up nice instructions for you. And that's generally kind of the pain point on the AlphaNet. If you tried to build Tezos itself and you're on Ubuntu, there are instructions on Tezos community, and I think also on the Tezos wiki, because Ubuntu does not have a current version of libsodium. So that causes a lot of people problems. Same if you're trying to build in Windows on the Linux subsystem, that you still need the Ubuntu instructions. So I think those are the biggest issues. And then I think people generally, by the time they get to trying a contract, they're more or less in it for the long haul. And I've yet to have anyone really ask me too many questions about the contracts themselves.
Cool. So do you have some stuff you want to show us in Emacs or anything at this point?
Yeah, so I wanted to kind of show the Emacs mode because I think it's a really great tool. It's really hard to write these contracts if you have to keep the entire stack in your head, especially as it gets bigger. So what we've done, and this is work based on top of Benjamin Canu and his Emacs mode, and I've been adding to it over the past few weeks to give stack visualization. So this is a data publisher contract. Basically, you give it either a signed piece of data, which updates the data that's stored, or you give it none, and it gives you back the piece of data. And so essentially what it does is it is going to have to look at the data and sort of walk through it. So it starts by duplicating the storage. And if you look at the bottom of the screen, I'm not sure if you can sort of see down here, you can see as I apply an operation and move my cursor around, you can see what's actually happening, how the stack changes. So it makes it a lot easier to write a contract.
Interesting.
Yeah, so this will do things like error reporting and in the current version, autocomplete. So I can start typing P and it'll, nope. okay. Well, that's a bug. Still a work in progress, I guess. But it's going to have hopefully more and more features as time goes on, and hopefully be a good way to write the contract and have indentation and things like that all provided for you.
Cool. So how you're working out of the Tezos offices in Paris? Tell us a little bit about the team of folks that are working there. What kinds of folks are you working with, and can you tell us anything about the size of it or complexity?
So the team is pretty small. Sorry, I'm going to stop sharing my screen. All right, I think I'm back. The team is small, but most of them have PhDs. And you can sort of look on the OCaml Pro website and see who they are. That's sort of the dev team. They're all very competent. They know OCaml extremely well. A lot of them are contributors to the language or the compiler, or have packages they maintain. And it's a really great place to work because everyone is super interested in the language and the project and trying to build this really cool project. And not just, we're going to do everything that everyone else has done. They're interested in, pushing into new ground, trying new things, and trying to figure out what actually is going to work and provide a safe and secure blockchain.
Awesome. So maybe speculation, maybe a little bit out of the realm of what you're comfortable with or even know about, but what are some of, if you have any ideas, what do you think are some of the major innovations that are going to roll out over the next 6 months or so from the team for people to take advantage of the infrastructure?
I think you're going to see a lot of work on sort of tools for smart contracts and things like that. I've seen some from members of the community that they built on their own that are really, really great. I think you're going to see a lot of tooling to help make it really easy to get involved. And once the network launches, I think you're going to see a lot of stuff that's going to make it easier to send transactions. There's talk about clients and things like that to make it very easy to interact with. Usability is one of the big focuses that I think is going to be discussed over the next few months. And then I also think there's a lot of sort of experimental ideas that are maybe not 6 months out, but a few years out that are sort of still in research. And then also, of course, formal verification and ideas like that. They're being discussed. Nothing in Tezos is really formally verified. There's a complete model of Michelson online on GitHub that you can see, but over time, I think you're going to see more and more of the protocol have some verification or some SFT solvers, some lighter weight tools at least, moving into heavier weight ones over time, probably. I don't know what's going to be verified at launch, but I think definitely it's going to be a focus sort of in the next year or two, like what can be verified, what can be analyzed.
Cool. So just two more questions for you. Again, more on the speculative side, but if a couple of talented young devs came to you today and they really wanted to build something interesting for the mainnet launch or shortly thereafter, what are some of the areas that you would direct people to try and focus on?
I think compilers for Michelson are going to be a big one. I also think making Tezos accessible is going to be a challenge. I think cryptocurrency is to a large degree something that we're going to be looking at in the future and that everyone's going to have access to. But it's right now, very volatile and it's very speculative and it's not necessarily a great experience if you're just trying to buy, you could buy a Bitcoin or two easily, but as time goes on, there's significant concerns about security and you have to verify your identity and things like that. So the more that can be made seamless, the better. And I think that's going to contribute a lot to Tezos' success. Making it easy, not just for the developer to be involved in the cryptocurrency, but for anyone who wants to get it, use it, understand it, and build great tools and things on the blockchain.
Awesome. Okay, and the last question is roll the clock forward to January 1st, 2020, a little bit over 2 years from now. How much is one Tez going to cost on January 1st, 2020?
I think your last guess said 15, which was kind of where I think it's probably going to end up. But I'm going to be bullish and say 20 because, I think it's a great project. And I think ultimately we've seen, like with the recent Parity wallet hack and things like that, there's a lot of issues on the blockchain that have not been solved. And though, Bitcoin's very large, we're seeing their governance issues flare up again. So I think as time goes on, people are going to recognize that Tezos offers solutions to these problems. And I think that's going to help it rise to new heights.
Awesome. All right. That was Milo Davis with the Tezos team. Thanks a lot, Milo. We look forward to following you online and hearing a lot more from you in the months ahead. Thanks, everybody, for tuning in here. We'll see you next week with our next interview with somebody interested in the Tezos community. Goodbye.